Hey everyone. So I already said this in the assignment sheet, but I want to say this now. One thing that I saw was lots of you would get stuck on a question and you wanted to work on it so badly. You lost track of time. So you ended up spending a lot of time on these assignments. And so what I did with this assignment is I've really broken it down by how much time you should spend on it, as if we were in class, knowing that at some point I would go over it if you got stuck. So our objective today is to learn how to start modeling word problems with slope-intercept and point-slope form. So the idea is writing equations to represent the situation in either slope-intercept or point-slope form. We're going to have 3 explorations where before I say anything, you're going to try on your own. As you see, I ask you to take 6 minutes to try to model it before moving on. When you think you have the answer, input it into play pause it. If you have no clue after 6 minutes, just write unsure and then watch the video on the explanation. And then you're going to then repeat that for 2 more questions. So I'm gonna scroll up a little bit. Here's the first one you're gonna do. So read the question. Best of luck. So these first 3 examples I am going to do in more detail. There's 5 practice at the end that I'll do in less detail. So here's what we know. There is a startup fee of $45. That means right away, that means 0 classes. This right here means 0 classes, and I have to still pay $45. And then we see that it's $6 per class. Now, another word for slope when it comes to word problems is rate of change. So in your notes, you should write that rate of change is equivalent to slope. It's a synonym, but it's what we discuss when we're dealing with a word problem. Now, we're looking at the information and we're told that we have the number of classes taken. So write a relationship where the number of classes taken and the overall cost are our 2 inequalities. Now, we have to think to ourselves, which one's the independent, which one's the dependent? So here's a strategy that I always do. I start by writing a basic ordered pair, x comma y, my general case. And I think to myself, which one represents the x? In this case, it's the classes taken. So T, comma, overall cost, C. I cannot tell you how useful this one little strategy is. Write the ordered pair with the information dealing with the situation. Because then hopefully you can see right here we have 0 classes, $45. Well, I can take that and now write it as an ordered pair, 0, comma 45. Well, whenever we have 0 in the x, this right here is the y-intercept. And so what we now see is we have the y-intercept 0, comma 45. We have the slope, which was 6, the rate of change. Well, if I have the slope and the y-intercept, well, then my goal is going to write slope-intercept form. So y equals a 6x plus 45. Now, one thing that I forgot to do was I had told you instead of y and x to use these specific variables. So we have cost is equal to 6 multiplied by the number of classes plus 45. So the best form for this word problem was slope-intercept form. If you need to, pause this video. Otherwise, let's go on to the next exploration. So for this one, I'm going to highlight one piece before I go. Remember, try to write the ordered pair with the context. But look at this. I bolded it on purpose and I'm highlighting it on purpose. So again, take 6 minutes. If you can't get it in 6 minutes, write unsure and then move on. So before I forget, use X and Y because I didn't tell you which variables to use. So all I did was, again, write an ordered pair below X comma Y with the information. So I have the years since 2000, comma, population in millions. So I'm going to start looking through this for years that match up with population. So the US Census Bureau predicted the population would be 17.4 million in 2010. Well, that's a population and that's a year. Okay, so that ordered pair right here is going to be 10 because that's years since 2000. 2010 is 10 years since then, comma 17.4. So that's my first ordered pair. I then see that it's going to increase by about 0.22 million per year. Well, an increase per year, that's again my rate of change. And so we're looking at this and we're saying, okay, I have the slope, I have a point. Well, the best form would therefore be y minus y1 equals m times x minus x1, point slope form. So y minus a 17.4 equals my slope, which is 0.22, x minus 10. This equation represents the situation. Now, if you want to, you could put this into slope-intercept form, and I'm just going to do it as a reminder. Now, I'm going to so this is all extra work. You didn't have to do this. I'm going to do it by converting. So I get a y minus 17.4 equals a 0.22x minus a 2.2. I'm going to add 17.4 to both sides, and I get y equals 0.22x plus a 15.2. So this is now slope-intercept form. And before we move on, I'm going to quickly talk about why this is interesting. Well, we now have the y-intercept. Well, the y-intercept is 0, 15.2. So this is my y-intercept. Well, let's think about what that means. Well, you know how we did that ordered pair at the beginning? Match it up. 0 years since 2000, that's 2000. I have a population of 15.2 million. So sometimes we can manipulate one equation into another based on the information I'm looking for. So again, feel free to pause this if needed to look this through. Otherwise, let's go on to the third one. Remember, 6 minutes max. Because I, again, didn't tell you which variables to use, let's again just go with x comma y. All right, 6 minutes. Okay, so hopefully as we're starting to do these and see them, we're hopefully starting to see some key information. So for example, we're starting at 12,000 meters above the ground. Well, starting means 0 minutes have passed. So this is 0 minutes, a height of 12,000 meters. Well, that's my y-intercept. Hopefully you're starting to draw this connection. Starting, whenever we see the word starting, or we see the word initial, something that is right away, that's my y-intercept. Now we're descending at a rate of 800 per minute. So that's a slope because it's my rate of change, but it's descending. So in this case, my m is negative 800. Well, we have the y-intercept, we have the slope. So let's go slope-intercept form. Y equals a negative 800x plus 12,000. I can now ask a question. Maybe I'll ask a question. When do we reach, whoops, that's not how we spell reach, reach the ground? Well, all this question is asking for is the x-intercept. Because when do we reach the ground? Well, we reach the ground when y, which is the distance from the ground, is 0. 0 equals negative 800x plus 12,000. Subtract 12,000 to the other side. We get negative 12,000 equals negative 800x. Divide by negative 800, and we get 800, let's see, divided by negative 800, divided by negative 800. Zeros cancel out. That's a 60 over 4. That's a 30 over 2, 15. So in 15 minutes, I get to the ground. So this is why we're going to start writing these questions. I might ask, what is the height after 5 minutes? Well, then we plug 5 in for x. So again, pause it if needed. Don't forget about this key information to add to your notes. Otherwise, we're going to move on. So these were the strategies that we just talked about. Define the variables first. Make sure you know your variables. Find information and write them as ordered pairs. So this is what I was saying, x comma y. What is x and y? Write them in. If you have the slope, great. Otherwise, find it. And then write your equation. Decide what info do I have. If it's a point and a slope, let's go point-slope form. If it's a slope and a y-intercept, let's go slope-intercept form. So here is your practice. There's 5 questions. Again, you should take about 6 to 7 minutes. Now these I'm not going to go in as much detail. So when you pause it to do this, I will then use or write out most of it as an answer key, and I'll talk about it for a little bit, but not in as much detail as the previous 3. Notice that if you don't complete this during class time, it's your homework. You should be spending 6 to 7 minutes max per question before writing unsure and listening to the explanation and then taking notes on the explanation. And I'm asking you to always use X and Y to make sure that you plug it into play pause it accurately. So here's the first one. Good luck. So here's your answer key to the first question, the first practice question. I was given the y-intercept. Notice again that it was det, so that's why it's a negative 224. I used the strategy of writing it as an ordered pair with words to then get to the ordered pair with numbers. I had the slope, and because I had the slope and the starting, which is my y-intercept, I was able to go straight to the equation, y equals 6x minus 24. All right, let's go on to practice 2. So here's practice 2, 6 to 7 minutes. So just like the last one, you were given the slope, the rate of change, and the initial setup fee, which is our y-intercept. So we use slope-intercept form. Now, before we go into practice 2, I want to quickly ask you a question and see how you guys would do it. Using this, so I want you to, in your notebook, show how you would do it. How much do I pay after 6 months? So think about how you would go about solving this question. Well, 6 months, again, look at our ordered pair, months, that's my x. So if I was to solve this, I would say y equals 43.49 times 6. plus 24.99. I would then have to do the math, and with that, I need my calculator. I get y equals 260.94 plus 24.99 plus 24.99. So y equals 285.93. So because I gave you the x, we plugged it into the x. But I could have also said how many months have I been paying if I've already paid a certain amount. Then you plug in for y and solve for x. So let's go on to practice 3. I'm just going to, again, highlight this. Think about that exploration we did in number 2. Look at your notes, 6 to 7 minutes, see how you do. So from this practice, you'll see that the ordered pair, so 1997, we saved 2,200. Well, since we're doing years since 2000, 1997 is a -3. So it's -3 comma 2,200. We're given the slope, 1,300. So our best form is point slope form. So here it is in point slope form. Remember, we substituted in a -3. That's why it became +3. Feel free to put it in slope intercept form. And if you were to do that, find out how much he had in 2000, because you'd be finding the initial. So 1,300x plus a 3,900 plus 2,200 plus 2,200. So y equals 1,300x plus a 6,100. So you didn't have to do this, but you could have. So in 2000, he had 6,100 saved. All right. Practice 4 is very similar to practice 5 or practice 3. But read this and decide which form is best. All right, best of luck. So, by defining X as years since 1997, well, then the value 1997 saved 2,200 becomes 0, 2,200, which this right here is the y-intercept, which means we could actually just use slope-intercept form. And this is why it's so important to think about how you define X. You can choose it. So you can have different equations that represent the same situation. But because of the way you've defined X, you have to be careful. Because in our previous example, the 6,100, because X is years since 2000, 6,100 represented what we had in 2000. But in this case, our y-intercept's 2,200. It's not that we did something wrong, it's that we're saying y-intercept is 2,200 because we're starting in 97 now. So I wanted you to see that difference and know that you can actually define it however you'd like, but you must stick to that for the whole problem. All right, let's go on to practice 5. Remember, 6 to 7 minutes max. Hopefully, we're feeling more confident now that we've had 3 exploration and 4 practice. So hopefully this isn't actually happening to anyone and that they're losing their gigabytes. But so we see that we currently have. Now, I know that when I said starting initial, that could sometimes be a little confusing because saying that we have 3 gigabytes left, that wasn't our initial. But it's the initial in the story. It's the start of the story. So that's our y-intercept. And we're using 0.2. That's why our slope is a negative 0.2. And this, therefore, is our equation. Slope-intercept form would be the best. Again, you could do point slope form. You could say y minus 3 equals negative 0.2 x minus 0. That equation is accurate. And so it's just whether one way is sometimes in a better form than the other. Now, I'm going to end this by, in the play posit, asking you a few questions that require you to use the equation. And I want you to use the equation, algebraic, show your work. And so there will be feedback after each question. Make sure you take a look at that feedback if you got it wrong. Have a great rest of your day, everyone. Bye.